Hey guys, I'm Taylor, and I'll be going over problem number 5 from the kinematics homework. So it's the diving board problem. So first I went ahead and just drew a little picture of what's going on. So we're given the problem. There's a diver jumping off the diving board. So here's the water, here's the diving board. The diving board is 1.55 meters above the water. The diver jumps off the board straight up with an initial velocity of 4.8 meters per second, and then falls straight down to the water, making the acceleration negative 9.81 meters per second due to gravity. So the first question is, how long are her feet in the air in seconds? So we're going to use the displacement equation. Over here, it's wrote it down right here at the top. So then you just plug in your numbers. So her initial position or final position is going to be negative 1.55 because she started at the top of the diving board. So we're starting, her final position is below that, so that's why it's negative. And then her starting position is 0. Then we have plus 4.8 meters per second because that is her initial velocity, times time, which is what we're trying to find, plus 0.5 times negative 9.81 meters per second, the acceleration due to gravity, times time squared. So we have to use a quadratic equation for this. So once you kind of move everything to the side, this is the equation that you get to plug into the quadratic equation, which is right there. So you plug in all the numbers just like that, and after you get through calculating all of that, you get x equals 1.2. So her feet are in the air for 1.2 seconds. Part B, what is the height above the board in meters of her highest point? So first you have to find the time it takes to reach the peak, and then use the kinematic equation for velocity. So first we're going to see how long it takes her to get from where she jumps off to the highest point. So right there is the equation for velocity. So we have 0 equals 4.8 meters per second. That's what we're given. Plus the acceleration due to gravity is negative 9.81 times time. So after you solve that, we find that it takes her 0.49 seconds to reach her peak. So then we have to plug that into the displacement equation. So after you plug those numbers in, we're looking for y. So we start out at 0, it's our starting point. Our initial velocity is 4.8. And then we multiply that by 0.49, the seconds it takes to reach the peak. And then 0.5 times negative 0.918, the acceleration due to gravity. And then times time squared, that was 4.9 again. And then you end up getting 1.17 meters. So her highest point above the board is 1.17 meters. Determine her velocity when her feet hit the water. It's part C. So in this, we're considering upwards the positive direction. So we need to use the kinematic equation for velocity. So, kinematic equation for velocity. Plug in our 4.8 plus our acceleration due to gravity, negative 9.81 times 1.2, and then we end up getting negative 7.309. So, I think something that people might get tripped up on is knowing that it's negative because since our upwards direction is positive, you can see that she's spending most of her time going in that negative direction. And then also the quadratic equation can be pretty tricky. So since I moved everything to the left side to make that first number positive, then that makes these two negative. And you need to remember that the quadratic equation is the ax squared plus bx. So technically you could put a plus there and then change that to negative 4.8 and then do plus negative 1.55, because that might help you out when you're actually plugging it into the quadratic equation. But if you put the subtraction or the minus like I did in here, you just need to remember that that's actually a negative 4.8 instead of a positive 4.8. So hopefully that helped you guys out a little bit with that problem.